Welcome. In this video, we will learn about the impact of compounding, multiple compounding of interest on the way we calculate the value, the economic value of a cash flow. So in previous lessons, we represented the interest as I%, and we kept saying it's compounding annually, or just we say I% per year. But in a lot of cases, the interest compounding, meaning that the calculation of interest is happening in less in a frequency that's more less than a year. So it happens more like a quarter or a monthly. So for example, like credit cards charge interest per month. So they don't wait until the end of the year to charge the interest on the balance of the credit card. They do this every month. So if let's say a credit card has a 1.5% interest on the unpaid balance each month, so this means that the interest rate here is 1.5% per month So bear with me here. That's not a repetition. It's not redundancy. This is kind of how we will represent some interest rates that are a little confusing, but we'll see how to deal with such situations. So it's 1.5% per month, and it's just confirm it's compounding monthly. So that 1.5% per month interest, if you kind of want to say how much is this per year, you would say multiply by 12. But this is the key here. This is not the true annual interest rate. It's what we call nominal. So it's kind of a fake, or not really representing the actual accumulation of interest. So let's and the point here is if you have the monthly interest, that period that's less than a year, if you want to say, all right, I will use the annual interest, it's probably what we covered so far, and we've shown using the annual interest. Even the A uniform series is called A. Kind of normally people imagine that the unit period is an annual. So just use the nominal interest, and we'll say this is the present worth based on that. So the calculations here are not correct if you're going to use the nominal interest. And let's show that by this example here. So let's track here the value of a $1,000 over a year, but let's do it in both ways. Like if we have 1% per month, so the accumulation of interest here per month, or I would say, you know what, I'm lazy, I will do it using the nominal interest, and I'll do it at the end of the year. So $1,000, the first period here, which is a month, so 1% of this is $10, and you start accumulating the interest until the end of 12 month periods, or 1 year, you'll have that balance here, 1,126.83. So the start of the period, SOP, and end of period, we track the value or the balance in the account that has this money in it, and that has the money in it. So this is one approach, which should be the realistic, most accurate way, because it reflects the actual accumulation of the interest here. Let's say now we're going to use the nominal interest. So I have $1,000 over one period of year. Using 12% nominal interest, I end up with $1,120. So there is a difference. Yeah, you might say it's $6.83, so it's not a big deal, but it's incorrect, right? So it's not the correct way that the interest is actually accumulating here. So when we have compounding period like that is less than a year, we call it multiple compounding periods within a year. The cash flow analysis need to account for that by either analyzing the cash flow that uses a period interest, which is that period less than a year, the interest based on that, or an effective annual interest rate. So let's say we have here a nominal interest rate, which is 18% per year, but compounded monthly, per month here. So I have to match this with that, this period with this period. So this word with this word. So I have to make it a period interest rate. So per month, or per quarter, or I have to make it effective interest rate. So it's per year, and if you compound per year, it will give you exactly the same compounding per month that's happening here. So let's see both approaches. So the approach one is using the period interest rate. And period interest rate, like we did the calculation the other way, we calculated the nominal by multiplying the period times the number of interest periods per year. So I can do it the other way. Period interest rate is equal to nominal divided by the number of interest periods per year. So if I have 12% per year per quarter, or per year compounded quarterly, divided by then my unit here is, or my period here is quarters, so dividing by 4, that's now the true interest, but now not per year, per quarter, per the period. So the number of periods here, when you use now draw the cash flow, you have to be careful of matching the time periods in that cash flow with the period that is represented into the interest rate. So let's say my cash flow is actually annual, so I have a P and value F after 2 years, and I'm giving here the nominal interest. But if you're gonna move from the nominal to the period, then also move the cash flow from the annual to the period. So instead of plugging in, if I'm plugging in a factor that says P given F I, which is now the period interest IP, and then N here would equal to 8, not 2. So the first approach, you have to match the period. If you're gonna base your calculations on the period that's smaller than a year, you have to bring the interest rate to the period basis, and also the cash flow, you have to have it as a period cash flow. So let's see this example here. So Thomas here purchases a car, 12,000, and finances by borrowing the money at 6% per year compounded monthly. So the interest here is monthly, not annual, but it's given to us on an annual basis. He pays off the loan with equal monthly payments for 5 years. What will be the size of the monthly loan payments? So if I draw the simple cash flow in this case, so I will have here the timeline, and I will say that my time is in months. So, and I have 5 years times 12, so that will be 60. So over 60 periods, Thomas here kind of borrowed here this amount. Actually, it should be borrowing this. So the 12,500 is a positive. So because he got the cash, he used the cash to buy the car, but he got the cash. So here that's 12,500, and then the negative cash flow happens at the end of year 1, which is the time when the first payment is due, and he will pay every month. I will just do like that, many hours, 60 hours, an equal amount, which I will call here A. So the unknown here is A, so that will be the cash flow here. And you see that I calculated, I'm given the nominal interest. So what I will do is I will calculate the period interest, 0.5%, by dividing 6% over 12, and my N is 60. So using now the formula to find A is this is the present worth of that. Of course, it's a different sign here, but I will ignore the sign for now. I'll say that's equivalent to all of these A's, but I will use here that A given P factor. All right, so you spread that amount over 60 periods using the factor A given P. So at the end, you are figuring out that the payment for this car will be 240 on some change. So That's approach one. The second approach is using an effective interest rate. And in this way, you will be able to use the cash flow as an annual cash flow, not a period cash flow. So in this, we have to calculate now the effective. Really, what's really, if I base my calculations on an annual period, so this calculation should match with if the actual compounding of interest per the shorter period than a year. So the I effective here, this is the formula, is equal to 1 plus R over M to the power M minus 1. R is the nominal interest and M is the number of periods per year. So if quarters, it's M is equal to 4. Month is M is equal to 12. So let's illustrate here that both approaches will give you the same answer, as long as you match the correct cash flow to the correct interest rate. So here, what's the future value of $1, just for representation here example, after 1 year of investment at a 12% per year compounded quarterly kind of account. So if I use the period interest, I'm getting this 12% from a year level to the period level, so I'm dividing by 4. So the period interest will be 3% per quarter. If I apply the F given P formula, and I have the cash flow here simple, it's just the FP, which is $1 now. I'm trying to figure out the F value of it after a year, which is in this case 4 periods. So the cash flow should be in quarters. So F is equal to $1 times F given P, 3% and 4. If you get this value from the table, 1 is equal to 1.12551. So the dollar will grow by around 12.5%. Now, if I use the effective interest, I have to calculate first the effective interest, which is will turn out to be 12.551%. And if I use that, now the cash flow is very simple. A P at now with one period of time or unit of time, which is just 1 year, because every calculation, all the calculations now are an annual calculations. So here my unit is 1 year, and I'm using effective interest, and I will get up the same future value that I end up with here. That I also got with the period interest rate approach. So either way will give you the correct answer. It's just a matter of using matching the correct interest rate to the correct cash flow. So let's see another example here, like how far would this compounding be severe, like really mess up the calculations if you use the nominal interest so let's see. So if we have here that 12% per year compounded semi-annually, that's we're trying to figure out what's the effective interest rate for this case. And then try to squeeze more the period. So instead of semi-annually, quarterly, monthly, weekly, daily, and until even like second. Of course, no interest is compounded per second, but we're trying to mathematically here see the impact of M in the formula here of I effective. So we see here that the impact of M is the larger or the more frequent the compounding happens, the larger the effective interest should be, which makes sense because you have more chances to get more interest or earnings on the money. But at some point you see after the day, like any more compounding beyond the day, there is no much difference, right? And then for each compounding here, I'm kind of calculating the number of periods, like seconds per year. This is the number, maybe that will be an interesting number for you. But you see after a day, increasing the compounding frequency doesn't really matter that much. So here M is, and this is why we don't see really like compounding interest that frequent. Per month, maybe per week is the most severe one, but typically it's per month or quarterly or per year. So let's see this example like finish with that. So Yingfeng borrowed this amount and paid off the loan in 3.5 years with a single lump sum. So he waited for 3.5 years, and then he paid with this loan in the form of $1,500 payback. Based on a 3-month interest period, so his compounding was quarterly. What was the annual effective interest rate paid in this case? So if I open the solution for this one, 1 minute. Yep. So this is the cash flow representing the case. So we have this man borrowed $1,000 now, and in 3.5 years he paid it back as $1,500. My M is 4 quarters per year, and the question is, what is the effective interest rate that was in place in this case? So what we're looking for is I effective. So I have P and I have F. So if I look at the formula, I have P and F, and I'm just missing here the interest rate. Now, I will follow the approach that 3.5 years is not a full number, so I will follow the period interest approach. So I will use IP to be the period interest, and my N will be how many quarters in 3.5 years. That will be 14. So now I have a full number. I'm more comfortable. I can use the tables. So if I try now to calculate IP, following now it will be one unknown in one equation. I'll find it's 2.94% per quarter. The question doesn't ask for period interest, it asks for effective interest. So I will apply the effective interest formula, which is 1 plus R over M to the power M minus 1. So I need to calculate R. So I calculate to be 11.76 per year per quarter. Now if I use I effective formula, one thing you will note here, R over M is already the period interest. So I didn't really have to calculate R. So you can just right away say, or have a new formula for I effective, which is I effective is equal to 1 plus I period to the power M minus 1. So just use I period, and you'll find that I effective is equal to 12.29%. That was the effective interest rate or time value of money that Yingfeng kind of had to deal with. There is another approach, which is let's ignore our irritation from the 3.5 years. Let's say that I will actually plug it in the formula right away. And if I use 3.5 years, this means my base of calculations is annual, which means here I will get my interest, or the time value of money in this case, right away as effective annual interest. So solving that formula for I effective, I will end up with the same, almost the same answer. The difference here of 0.01% is just a rounding error. So you see there are two approaches here: a period cash flow and period interest, or an annual cash flow with effective annual interest. So that was it. I hope you appreciate now the idea of that credit card companies charge monthly, not annually. And of course, if they don't let them fool you by saying the nominal, this interest is just multiplied by 12. This is not the actual real effective interest. So that hopefully will help you in figuring out your own finances. All right, thank you so much, and I'll see you in other videos.